Hey class, this is Mr. Werkesser. I'm back on chapter 2.7. We're doing vertical stretch and compression of absolute value equations. So let's show you again what we're doing here. We just finished that part. Now we're on problem 4, identifying transformations. We have Desmos going for you also. You can see how one from the parent function can be transformed up 2 units with a wider compression. Let's get rid of those. Let's go back to here and see what it looks like with problem 4. What are the vertex axis of symmetry and transformations of the function y equals -2, absolute value of x minus 1 minus 3? And so you're going to compare these also to everything involved here with this general form of A, which is the compression, which I'm going to write on the board tomorrow, but A equals the compression, right? This is your compression right here. Sorry, my typing's a little slow. And then your H right here, negative H is going to be your X marker there. I'm writing it, but it should be, this should be right here. I'm sorry. Let's just go through and do this. This is -2 is A, right? Your H is right here. It's negative H. So it's actually just going to be a 1. And your K is over here. And that's -3. So let's take the eraser here, see if this works. There we go. And negative H, that equals your X. And your Y is going to be this K right here. So K is going to be your Y. And you can remember it's alphabetical. Just like X comes before Y, H comes before K. X, Y, H, K. So now we have to do a couple things down here, 16, 17, 18, 19. This is the function y equals -2, absolute value of x minus 1, minus 3. The vertex is what? What is the vertex? Here it is right here. Vertex is 1, -3. And how do we find the vertex? Well, if the h is 1 and the k is -3, well, guess what? 1, -3. So the vertex is, if it's a positive graph, the vertex is right here. It's the lowest point. That's your vertex. If it's a negative graph, your vertex will be the highest point, which is difficult to understand without seeing a picture. But if it's negative, the vertex is the highest point. If it's a positive graph, which means opening up, the vertex will be the lowest point. The axis of symmetry. What is the axis of symmetry? Axis of symmetry should be x equals 1. Okay, and why is that? Well, here we go. We go 1, and here's h is 1. 1 here, 1 there, and the axis is 1 here. It's 1. So that is going to be 1. The function is translated, and this is going to be 1 unit. Why is it translated 1 unit? Right? To the right. Because that, again, that's your x. And it's translated 3 units down. Right? And that's going to be your y. Remember, y goes up and down on the graph. And it's going to be a -3, so it's going to be down. Right is positive. So 19, the function is stretched, not compressed. And we say it's stretched because we have this, where do we have it at? Here it is. It's stretched -2 by a factor of what? 2 reflected across it's going to be the x-axis. Okay? Any questions? Come see me. Let's do number 5 now. Writing an absolute value function. What is the equation of an absolute value function? Right? So complete the model to write the equation. The A right, is what? What is the A here? Look, if you start here, you go 1 up, 4 over. Or you can go 1 up this way and 4 over this way. 1, 2, 3, 4. So the A is going to be 1 over 4. And the identify the vertex. The vertex is this point here, the lowest or highest point. So the vertex is 2, right? And -1. So here's 2, and here's -1. So this is how you write the graph, or you can graph one of these with the formula. And so let's make this equation by putting this information in. So here's the A, y equals A. What is the A? 1/4. So we're going to put a 1 here and put a 4. I hate making a sideways fraction, but I have to because I have much space right here. Then you're going to put your X, right? Or your H. Here's H right there. Remember, it's going to be a negative. So if it says 2, it's going to be -2. And then this right here would be a -1, right? So there's our equation. The equation we need to write again right here for some weird reason, but you have to write it again. And I'm going to do it myself, so you should be able to do it too, even though mine's a lot more work than it is for you. Make sure you do absolute value bars, not parentheses. And you can put this into Desmos and be fine. And you don't have to put +1, you can put just -1. Plus -1, I mean, you can put -1. So there's your equation. Now, lesson check. Do you understand? I'm going to try to help you with this a little bit. Is it true that without making a graph of the absolute value function, you can describe its position on the graph? Explain with an example. Yes, it is true, because we just talked about that. You can graph something with just this equation right here. So here is an example. Circle each function. So the function of y equals x reflected across the x-axis looks like this. Negative. And number 23, the function of y equals x translated 3 units to the left and 2 units up. It's going to look like this right here, folks. 3 units up, 2 units. Sorry, 3 units left, 2 units up. So there we go. Those are your answers for that. And if you want to do this, that'd be nice also. Just a little practice. Grab your homework when you're finished. Do your homework. Have a great day, and I'll see you tomorrow. See if I can figure this out now before I mess everything up. There it is over here.